about equations and variable equations, we can go about solving them. First, we'll go over our 2 vocabulary words. Our first one is inverse operation. Inverse means the opposite, undoing something. So the inverse operation is 2 operations that undo each other. In mathematics, addition and subtraction are inverse operations, so are multiplying and dividing. Next is number 2, an equivalent equation. Those are equations that have the same solution. If you notice, equivalent, equation, equal, same Latin root. Today we have 5 examples. Let's take a look at our first one. The directions are very simple. Solve the equation. And what my purpose here for you is to learn how to go about solving equations. I purposely gave an equation that is something you can do mentally. And the reason I did that is so that you can learn the process with an easy fact, so that as the math gets more challenging, you will have already been proficient in the strategy that I'm showing you now. We have x plus 12 equals 8. And what we need to start doing is recognizing that we need to look at this as though we have 2 different terms on the left side of the equation. We have an x and we have a positive 12. Now our goal, our aim when we're solving equations is to get the variable by itself. And right now our variable is being kept company, so to speak, with a positive 12. So what we need to do is negate that positive 12. We need to pair it with a number that will, with it, make a 0. And that's where inverse operations comes in. Now, what we have to ask ourselves is, what's the opposite of a positive 12? And way back when we were first learning integers, you already know the opposite of a positive 12 is a negative 12. So the way to take care of this side is to put a negative 12 here. But because this is an equation, and both sides have to be equal, whatever we do to one side of the equation, we must do to the other. So what that means is we are going to put a negative 12 on both sides of this equation. So we'll write exactly what we started off with here, and then we will apply our negative 12. Then we will bring down this number 8, because that's what we have, and then again, we will apply a negative 12. So what we've done on the left side of the equation is we have paired a positive 12 with a negative 12, and together they make 0. So on this side, we have x plus 0, which you know is just x. And here, again, we have to look at this as 2 separate terms. We have a positive 8 and a negative 12. And if you remember your rules of integers, you know that when we're combining a positive and a negative number, we have to actually subtract the 2 numbers from each other, which gives us a 4. And because 12, being the number that looks higher, is a negative, that means that our answer is negative 4. And there's an easy way to check this if you wanted. If we go back to the original equation, and we have x plus 12 equals 8, and then we take our solution and substitute it in, negative 4 plus 12 equals 8. Again, we have our rules of integers. We have a negative and a positive, so we subtract the 2 numbers. 4 from 12 is 8. And because our higher looking number, the 12, is a positive, our answer is a positive. And as you can see, 8 does equal 8. Negative 4 is our solution. We're going to put this into practice for example 2. Now I did something a little bit different here just to get you used to it. Oftentimes when we are presented with equations, the variable is on the left side of the equation, and I'm doing this to help you to understand that it really doesn't matter where it sits, because one side is equal to the other, given that this is an equal sign. But I know it's uncomfortable for some people to have it here, so it's best to practice with it and then you'll get used to it and lose that discomfort. So what do we have here? We have 15 equals m minus 12, but remember, we're looking at this as an m and a negative 12. Inverse operations, we have to do the opposite, because what do we want? We want for the m to be by itself. We need to isolate the variable. So the opposite of a negative 12 is a positive 12. So what we're going to do is put a positive 12 on both sides of this equation, because remember, in order to keep it equal and balanced, whatever change we make to one side of the equation, we have to do to the other. Let's simplify the left side first. 15 plus 12 is 27. And what do we have here? We have our m, and this negative 12 and positive 12 together made a 0, m plus 0. And then we simplify it to 27 equals m. So the solution for this equation is positive 27. On to our third example. Now we're going to start with some word problems. Let's take a look at our story. There are 128 students who run track this year. This is 32 fewer than last year. How many students ran track last year? And I know that word problems are daunting for a lot of students. A lot of students don't like all the words, they get lost, they get confused. And really, word problems force you to think, so they're really not as appealing as doing just a problem. But I want you to remember that it's important for you to have a real-life situation where you can apply the math that you're learning. And so what I did was I started us off with our variable equation. We know that there are 128 students running track this year. We also know that this number is 32 less than last year. So we have x representing the number of runners from last year. And we are putting that with a negative 32 because that's what 32 fewer means. We're taking 32 away from our original number. And so now what we have is just a problem like we had in our first two examples. We want to find the value of the x. And in order to do that, our goal is to isolate the variable. Right now, the variable is paired with a negative 32. And we need to get rid of that negative 32 so the x can finally be alone. So we have to think about our inverse operation. We have to ask ourselves, right now, x is being paired with a negative 32. What's the opposite of a negative 32? Positive 32. So what we're going to do is put a positive 32 on both sides of the equation. Remember, we bring down both these terms exactly as they're presented to us. And then we apply our positive 32. Now we just simplify. 128 plus 32 gives us a sum of 160. We have x with a negative 32 and a positive 32. These two together make a 0. So x equals 160. And then your final answer, which I don't have room to write here, you know will be a complete sentence. 160 students ran track last year. Okay, another perimeter problem. Here we have a triangle, and your directions are to find the length of side W. And just a reminder, you know that the perimeter is the sum of the sides of the figure. We're basically adding the figures to get the perimeter. Now what was our equation going to be? Well, we're going to start, we know that our perimeter will be the addition of all three sides. And our perimeter is 41 inches. So what does 41 equal? It equals 15 plus W plus 17. And the first thing we're going to do is notice that we have two constants on this side of the equal sign. So what we're going to do is simplify that side. So for right now, we are just bringing down this 41, and we're going to combine our like terms. 15 plus 17 equal 32, and we cannot forget this positive W. Now, what we're going to do is solve this problem the way we've solved our first three examples, getting the W by itself. Right now, W is being kept company by a positive 32. So what we have to do is put a negative 32 on both sides. That way we can make the W be paired with just a 0. And you know, because you're already familiar with the identity property of addition, any number paired with a 0 equals itself. So we have 41 already, and we have to put our negative 32 here. Then we're going to write this expression exactly as it is. And then we are going to tack on our negative 32. Now it's time to simplify. 41 minus 32 equals 9. 32, this positive 32, and this negative 32 make a 0. When a 0 is added to W, we have just W. And again, I ran out of room, but your final answer will be a complete sentence. Side W is equal to 9 inches, or side W is 9 inches long. We have one more example until we're done for today. We have a little bit of social studies. I'll read this to you. The Great Pyramid in Egypt was built at around 2,560 BC. Over the years, it has lost 30 feet of height off its top and is now only 451 feet tall. What was the Great Pyramid's original height? And so again, I started us off by writing out our variable expression. Our original height minus 30 feet equals the 450 feet that it stands now. And by now you're probably a pro at this. In order to get the x by itself, we need to negate this negative 30. Now, according to our inverse operations, you know the opposite of a negative 30 is positive 30. And that's what we are going to put on both sides of this equation. What we're left here with is just an x, because the negative 30 and the positive 30 make a 0. And we learned that the original height of the Great Pyramid was 481